Okay, in this video, what I'd like to discuss with you is what's commonly called the periodic trends. These are the trends in certain properties that we see in the periodic table, and we can predict these properties and make comparisons between the elements simply based on their position on the periodic table. So the periodic trends I'd like for us to look at are ionization energy, electron affinity, and then atomic or ionic radii. Okay? First I would like to start with atomic radii, then we'll move from there. Okay, so with atomic radii, what we're discussing is the actual size, or in terms of the diameter or the radius of the atom. Okay, we're looking at the actual size because atoms are generally spherical shape, and so we're measuring that radius across the atom there. So let's look at the atomic radii. So with atomic radii in periodic trends, what we're doing is we're making comparisons of the atomic radii of the elements simply based on their position in relationship to one another as we move across a row, and rows on the periodic table are often called periods. Okay, periods. And they're labeled as period 1 is across the first row, period 2 the second, and then third, fourth, fifth, sixth, and seventh period. Okay, so we could say that this is period 1, period 2, 3, 4, 5, 6, 7. So just remember what row they're on, and what row they're on, that's a period. And then groups are those elements in the same column. Okay, for example, this group right here, often called group 18 because it's the 18th column. The 18th group, as you count across the periodic table, is known as the noble gases. And then next to them is group 17, here with fluorine, chlorine, bromine, and so forth. These are called the halogen family. Okay, the halogen family. There's some very reactive nonmetals here. And a couple other groups that have selective or special names. This first column, first group of elements, these are metals. These are called the alkali metals. They're very reactive metals. And then next to them, these right here were magnesium, calcium, this column here. This is the group 2 elements called the alkaline earth metals. Okay, so groups are the columns and periods are the rows. And we can make some comparisons about certain properties just based on the row and where these certain elements are placed, or how they relate to one another in a certain column or group. Okay, so with atomic radii, now so far in chemistry you've studied atomic structure and so forth, so you should know that as you increase in atomic number down a column, so like for example here from nitrogen with 7 atomic number, 15 for phosphorus, 33 for arsenic, and so forth. As you increase in atomic number, you're increasing the proton count there in the nucleus, but at the same time you're also increasing the electron count, and electrons go on energy levels that encompass or surround the nucleus. Okay? Those energy levels have certain maximum counts of electrons, 2 on the first energy level, 8 on the second, 18 on the third, and 32 on the fourth. So as those energy levels fill up, you move to the next energy level, and the radius of the atom would increase. So as you move down a column, down a group on the periodic table, the number of principal energy levels that occupies and houses the electrons increase. Therefore, the radius, the atomic radius, increases. Okay? Alright. So as you move down, there's more principal energy levels housing the electrons, causing the radius to increase, to show a steady increase. Now, as we move across a row on the periodic table, as we go from left to right, one might think that, well, the atomic number is increasing as well, and so is the electron count. So one might think, oh, well, we're increasing the number of energy levels, like we did as we moved down the periodic table. But when we move across a row, a period here, okay, so let's take, for example, this sodium, period 3. As we move across, these are going into the third energy level, okay, what we would call the 3s orbital. As you continue across the periodic table, and you come over here to aluminum and silicon and phosphorus, these electrons are occupying the third energy level as well, but they're going into what we call p orbitals. So as you move across a period on the periodic table, you're placing the electrons in the same energy level. Okay, in the same energy level, so they're not getting further from the nucleus. So there's not the traditional increasing in radius. What we see is as we move across the periodic table, left to right here, the electron count does increase. The electrons go in the same energy level across, and the nucleus, as we go across, is increasing in positive charge because of the addition of a proton as you move across. Well, the nucleus becomes greater charge, what we call effective nuclear charge, the charge that is felt by the valence electrons, okay, those outermost energy level electrons, because that nucleus is getting bulkier and getting more charged than the force of attraction between the nucleus, positively charged, and the surrounding valence electrons increases. Okay? So it increases, and what we get is a decrease in the atomic radius. Okay, so as we move across a period, as we move across the row, we see a greater nuclear charge because of the increase of the positive protons in the nucleus, which will cause the valence electrons to be attracted in to that nucleus, and we see a shrink. We see a decrease in atomic radius as we move across. So let's try one for example. Okay, so as if we had boron, and we had beryllium, and we had lithium, and so we had lithium, beryllium, and boron, and as we move across the period, we would be seeing a decrease. So boron and carbon and nitrogen, oxygen, and fluorine, as we move this way, these would be getting smaller. As we go towards the left, okay, we would see an increase in the radius. Okay, and then as we move down, okay, so we go from period 2, energy level 2, period 3, energy level 3, and 4, and period 5, and period 6, we see the addition of those energy levels, those layers surrounding the nucleus, okay, that house the electrons. We see an increase in the number of those layers, much like an onion has multiple layers peeling, laying on top of one another, and as those layers, the number of layers increase, the radius increases.